네, 안녕하십니까. 방금
Good afternoon. I belong to the KRISO, but right now I am in charge of the cost project co-funded by the MOF and MOTI, and I am currently leading the cost project. Let me just briefly introduce to you the cost project, the Korean Autonomous Surface Ship project. And as you heard from the conclusion of Avica's presentation, let me show you how the technology can be verified. This is the order of my presentation. I will be mainly focusing on our validation process, what type of test infrastructure are being prepared, and the validation process that we are currently thinking of and what the scenarios are. And not only domestically, but internationally, validation will be an issue. So let me summarize with that. This project started in 2020. We are now in the third year of the project, and in 2025, the project will come to an end. MOTI, MOF are co-funding the project, and there is also a matching fund from the private sector. Ulsan City, Metropolitan City, is also a part of building the testbed infrastructure. A total of 51 organizations are a part of the COST consortium. Universities, shipbuilding companies, shipping companies, any companies that are engaging in research and development of technology regarding ports and ships. And KRISO and other research institutes are together a part of consortium. And KRISO and KR, the Korean Register, are the main leaders taking charge of the project management. So there are 4 core technologies. Number 1 is autonomous navigation system. Number 2, autonomous engine system. And number 3 is building the testbed and verification techniques that will be used to validate the technologies. And finally, operation techniques and standardizations, how that relate to how the actual autonomous ships will be operated and how international standards can be developed, as you heard from Ornov. Well, we now have a 24-meter long vessel that was launched this year as a test ship, and next week in Ulsan, remote controlling and monitoring center for autonomous ships will be completed. The remote control center will be completed next week. And from 2024 to 2025, the final years of the project, Pan Ocean ordered 1,800 TEU container ship will be where we will be attaching the developed technologies and systems for real-world validation. Let me introduce to you the results so far, starting with the situational awareness system that we call ISAS, which involves cameras, radars, LiDAR systems, GPS, IMU, and AIS. Within the OS, we have already developed a system to be aware of the situation. And automation of engine room is also very important to back up the autonomous ship system. The engines may become electrified, but it's very important to first automate the engine because there are many different failures that we see in the engine room. So we place the engine room onshore and test out the failure mode by creating artificial failures to see how the failures are detected and predicted. And next week in Ulsan, like I said earlier, the Shore Control Center will be opening. And there are different technologies that can be tested here. Simulation-based tests can be conducted, and the 24-meter test ship, as I mentioned, and as shown on the slide at the right-hand side, is also ready. And this is the autonomous ship remote monitoring and controlling digital twin bridge to be installed in Ulsan right now. It is located in the KRISO base in Daejeon. Ultimately, this system will be installed in Ulsan. So, in the end, the existing vessels are led and driven by captains and masters who are highly educated from maritime universities and higher education institutions. But when we use autonomous ships, who are we going to trust to operate those ships? How are we to trust such AI captains? How do we test them? How do we score them? So those are the main questions we are looking into as of now. And so we need to do both sea trial based validation and simulation based validation. We need a set of process to validate this and also to evaluate the system. To conduct these tests, a number of autonomous ships will be developed in the future, and they will be handling data in different manners. And so we need to test the data interface first. And there are some where there's a high risk of collision. It is not easy to test out those situations with actual ships. So we need to use virtual ships or set up a virtual situation to test out the risks to avoid collision. And for very difficult situations as well, we can use the virtual system. So this is what we do with our simulation-based tests. And then there will be the sea trial tests. And ultimately, we will use a mixture of actual ships and virtual ships in a hybrid test, which is also being considered. And we have a number of different digital systems. So in what scenarios are we going to test out those systems? And we are currently writing out the scenarios first with a situation awareness system. The colored dots on the map indicate fixed targets such as buoys that the ship needs to avoid. So we test with the constant heading situation to see if the ships are aware of those targets, and also with the course changing scenarios to test the same. These are the scenarios being developed, and the green ship is the test ship. So we want to also see whether the ship is aware of moving targets and also a mixture of both moving and fixed targets. So these are the scenarios that we are currently writing. And we also need to test the actual collision avoidance algorithm, whether the algorithms are accurate. First with the single traffic, when the other ship is coming head on or crossing or overtaking the test ship. So we are considering a number of different such scenarios. And we also need to test a multiple traffic ship scenario where there are a multiple number of ships that the test ship needs to avoid, and we need to see whether the collision avoidance system is working properly. But as you heard from Abacus and from Europe, there are a number of different autonomous ship systems that are being developed, and the collision avoidance is being well done. But what's the level of difficulty and complexity that's involved in when the test was done? This is unclear. And globally, how do we evaluate the AI captains of these ships? This question remains unanswered largely, so we need to work together globally. The technical experts need to look into this issue and propose some solutions. So the level of difficulty of the scenarios tested should be defined for the insurance companies and also for the ships to actually sail well offshore. So we need a set of standards. This scenario is the one that we have developed to be as complicated as possible. We have the four, as you can see in the blue route, we have 4 corners that the ship has to turn. And we have different traffics that come across the route. As the test ship turns each corner, it comes across a number of different situations, and in reality, it will come across thousands of different situations. So we want to test out how the ship is working and properly avoiding collision. And what's also nice about this scenario is that perhaps for not so much for ocean-going ships, but for most of the vessels, they adhere to the IMO collision coal reg, but not so much for fishing vessels. So those vessels that violate coal reg, we also need to test those situations where the test ship comes across vessels that are in violation of coal reg. So this seems like a computer-generated graphic, but this is actually what we tested out on sea, 2-meter with a 2-meter vessel. So we just added a few computer graphics for your understanding. So you can see that actual ships are in traffic, and the wire-framed vessels are the simulation-based virtual vessels. So we created a very complicated scenario, as you can see here. About 1,700 different encounters with other vessels have been created in this scenario. And the algorithms that have been developed so far, where there's no wave and this test was done in a waveless lake, but the 24-meter test ship will be testing out the same scenario, and then after that 1800 TEU grade container ship will ultimately be used for the final validation. So for now, different units of technologies are being developed as part of KRISO project, and what we also need to consider is that once autonomous ships are actually commercialized, how do we discuss all these matters globally? How do we evaluate the autonomous ships? And later, when the ship registers, give certifications, what type of certifications will be issued? So those are the questions we need to have in mind as we develop the technologies, and we need to make some solutions and propose solutions. We can't do this alone. We need to work with other nations. As for now, Lloyd's Register, ABS, DNV, and other large registers, they do have a validation system for each of their own digital systems, but the problem with autonomous ships is how the digital systems all come together and get integrated, and what kind of issues will arise once that integration happens, and how do we evaluate the integrated system? No one has an answer or a proposal to that. So these are questions that remain unanswered, and the IMO has proposed the autonomous ship levels, just very simple 4 levels, but those 4 levels are not really sufficient to be the clear basis on issuing certifications in the future. So we need to break that down further into more specific levels. And as Dr. Kim from Abacus has mentioned earlier, we need a scenario procedures to evaluate the autonomous ships with simulations or actual sea trials. And to conduct these procedures, we need a testing infrastructure and procedure for evaluation that also need to be standardized globally. And through the KRISO project, from Korea's perspective, and also on combining the different exchange of ideas with other nations in the process of conducting KRISO, we will present appropriate scenarios and procedures. Thank you very much.